In the modern shipbuilding industry, welding has become the main method of connecting the hull structure and metal components. And it is one of the key processes of offshore engineering structures and ship construction, and directly affect the quality and construction cycle of ships and marine engineering. The electrode arc welding we are talking about today is a welding method that uses the welding arc generated between the electrode and the workpiece as the welding heat source to melt the workpiece and the electrode, thereby obtaining a solid welding joint. Electrode arc welding has the following characteristics. 1. Simple equipment in electrode arc welding. As long as there is a welding machine for electrode arc welding, welding tongs, welding cable mask and other simple equipment, the welding can be carried out. 2. Flexible operation. It can be used for welding in various positions, and welding can be carried out wherever the electrode can reach. 3. Wide range of applications. Electrode arc welding is widely used in the welding of low-carbon steel, low-alloy steel, stainless steel and non-ferrous metals, special performance materials. 4. High requirements for welders. The welding quality of electrode arc welding, in addition to the selection of appropriate electrodes, welding process parameters and welding equipment, mainly depends on the operation skills and experience of the welders to ensure. Ship welders need to obtain certificates of conformity recognized by various classification societies before they can work on ships. 5. Low productivity and poor working conditions. During the welding process, the welders are exposed to the radiation of arc light, work in the environment of toxic and harmful smoke and gas, and are baked by high temperature. So the working environment of the welders is poor. Affected by the physical condition of the welder, the electrode needs to be replaced during the welding process. So the deposition rate is low and the productivity is low. Now we talk about the welded joint form. Welded joint refers to the joint form formed by welding. Welded joint includes two parts: fusion zone and heat affected zone. There are many types and types of welded joints. There are many factors that determine the type of welded joint, depending on the position of each other. There are mainly the following types of welded joints. 1. Butt joint, which is the most common joint form in metal structure welding. In the steel hull structure, this joint form is often used for the splicing of the hull outer plate and the butt joint of the deck plate. According to the different thickness of the plate, in order to ensure the penetration of the weld, the butt joint can be divided into two forms: grooved and non-grooved. This is a non-grooved butt joint. This is a beveled butt joint. With the increase of plate thickness, in order to ensure the penetration of the workpiece, it is necessary to increase the assembly gap, which brings great difficulties to the welding seam forming. The bevel is designed according to the design or the needs of the process. A groove with a certain geometric shape and size is machined in the part to be welded of the workpiece. This is a T-joint. It is a joint that connects the mutually perpendicular welded workpieces with fillet welds. About 70% of the welded joints in modern steel hull structures are T-joints. The angle joint is a joint with an included angle greater than 30 degrees and less than 135 degrees between the end faces of the two welded workpieces. In the steel hull structure, the connection between the longitudinal and transverse members and the outer plate of the hull is mostly in the form of this joint. Lap joint, which is a joint in which two workpieces to be welded are partially overlapped and connected by fillet welds, or by plug welds and slot welds. in addition to the consumption of many steel plates. This kind of joint will lead to low bearing capacity of the joint when it is subjected to external force. This joint form should be avoided as much as possible in the structural design. Termination joint, which is a joint in which two workpieces to be welded are placed overlapping, or the included angle between the two workpieces to be welded is not greater than 30 degrees to connect at the end. This type of joint is often used for sealing. Basic operating techniques of electrode arc welding. When arc welding with electrodes, whether the weld can be formed correctly and whether there are welding defects depends to a large extent on the technical level of the welder. The basic operating skills of welders include arc ignition, strip transportation, welding seam connection and finishing. Arc ignition: we usually use the method of contact arc ignition during arc welding. When starting the arc, the end of the electrode is contacted with the surface of the weldment to form a short circuit, and then the electrode is quickly lifted by 2 to 4 mm to ignite the arc. There are two ways to strike this arc. 1. Vertical arc ignition: the electrode is in vertical contact with the workpiece, and then the electrode is quickly lifted by 2 to 4 mm. After the arc is ignited, the electrode is kept at a certain distance from the workpiece. 2. Scratch arc ignition. This method of arc ignition is to align the end of the electrode with the weldment, and then swipe the electrode across the surface of the weldment like a match to generate a welding arc. Vertical arc ignition is generally suitable for acid electrodes, and scratch arc ignition is generally suitable for alkaline electrodes. Transport bars in the welding process. The general name of various actions performed by the electrode relative to the weld is called transport bars. The quality of the weld seam has a lot to do with the correct shipping. When the arc ignites, the electrode should move in 3 directions. The first movement is the feeding of the electrode to the weld pool. The second movement is the electrode moving along the welding direction. The third movement is the lateral swing of the electrode. The common ways of lateral swing are straight line reciprocating movement method, zigzag movement method, crescent movement method, triangle movement method, and circle movement method. 3. Connection and finishing of welds. 1. Weld connection during arc welding. Due to the limitation of the length of the electrode, the welds are connected segment by segment. Can be connected evenly. Welding seam connections usually have these 4 forms. 2. Finishing of the welding seam. The finishing of the welding seam refers to the process of ending the arc after the welding of a welding seam. After welding, if the arc is suddenly extinguished, an arc crater below the surface of the weldment will be formed. Excessive arc crater will reduce the strength of the end of the weld, and easily cause stress concentration to generate arc crater cracks, and it is easy to generate pores when using low hydrogen electrodes. There are 3 correct closing methods. 1. End of circle method. The arc moves in a circle at the end of the welding seam until the arc crater is filled, and then the arc is slowly elongated and extinguished. This method is suitable for welding of thick plates. 2. Repeated arc breaking ending method. At the end of the weld, the arc is repeatedly extinguished and ignited several times until the arc crater is filled. This method is suitable for thin plate welding. 3. Reflow ending method. The arc stops at the end of the welding seam, and at the same time, reflow the electrode in the opposite direction for a short distance and then extinguish the arc. This finishing method is suitable for the welding of low hydrogen type electrodes. That's it for electrode arc welding. Thank you for watching.